Okay, good day everyone. Now we are in the lesson 5.4, conducting small sample tests about a population mean mu. So our lesson outcomes, at the end of the lesson, the learners are expected to know what the method to apply when conducting tests with small samples and know why appropriate methods should be applied in statistical procedure. Reality tells us that hypothesis test situations may deal with large samples or small samples. There are appropriate approaches to use so that the errors in decision making are minimized, if not completely eliminated. At this time, we are going to show the diagram of what we are going to use if in case the sample size is more than or equal to 30 or less than 30. And this diagram is population standard deviation sigma known. If it is yes, then we are going to use the z-test formula. And we consider that the sample size is more than or equal to 30. What if the sample size is below 30? Then we can use the t-test formula. Okay? So ito yung ating diagram ngayon. The t-test formulas. When the sample size is less than 30 sample units, we shall use the t-test formula as follows. For t-test, using one sample mean, we have the formula as statistic t is equals to the quantity of a given mean minus hypothesized mean times the square root of sample size all over standard deviation. While for the t-test using two sample means, ito naman yung ating gagamiting test statistic. T is equals to the absolute value of mean 1 minus mean 2 all over the square root of the quantity of variance times sample size minus 1 of the group 1 plus variance of the group 2 times sample size of group 2 minus 1 all over n sub 1 plus n sub 2 minus 2 times to the 1 over n sub 1 plus 1 over n sub 2. So, depende kung anong ang iyong gagamitin. If it is one sample or two sample means. Okay, this time we are going to illustrate how to use this small sample test, both the population mean, by illustrating an example. Sample number 1, drinking water. Drinking water has become an important concern among people. The quality of drinking water must be monitored as often as possible during the day for possible contamination. Another variable of concern is the pH level, which measures the alkalinity or the acidity of the water. A pH level below is 7.0. It is acidic, while a pH above 7.0 is alkaline. A pH of 7.0 is neutral. A water treatment plant has target pH of 8.0 based on 16 random water samples. The mean and the standard deviation were found to be x bar is equals to 7.6 and the standard deviation is 0.6. Thus, the sample mean provide enough evidence that it differs significantly from the target mean. In other words, does the sample come from a population whose mean mu is the same as the target pH of 8.0. Use the significant level alpha of 0.05 with two-tailed test. To answer the question, we apply the hypothesis testing. First, we note that the sample size is 16. Thus, the central limit theorem or the CLT cannot be applied. So we cannot use the normal distribution as a model. Instead, we must assume that the parent population from which the sample comes is approximately normal. In this situation, there is more appropriate distribution to use, and that is the T distribution given by test statistic T is equals to the quantity of X bar minus mu sub 0 times the square root of n all over S, where the mu sub 0 is the hypothesized value of the population mean mu. Step 1, describe the population parameter. The parameter of interest is the mean mu of the population where the sample comes from. Formulate the hypothesis. So yung ating null hypothesis or H sub 0 is mu equals 8.0. Iyan din yung ating target na mean. Then ang ating alternative hypothesis, H sub A, is the mu is not equal to 8.0. Check the assumptions. Is the sample size large enough for the CLT to apply? No, since the sample size is 16, hindi natin pwedeng gamitin yung CLT. Samples are assumed to come from normally distributed parent populations. Are the samples selected randomly? The samples are assumed to be random selections. Step 4, choose the significant level for alpha. So, ang alpha natin ay 0.05. Ano yung ating test? So, by two-tailed or one-tailed? Sabi dun sa ating scenario, it is two-tailed. Get the critical value from the test statistics. So, sa pagkuha ng critical value, gagamitin natin ang T-table. Ito yung nasa inyong textbook, page 170. Dahil ang ating sample size ay 16. So, pag kinuha natin ang degree of freedom, minus 1 yung sample size. So, magiging 50 na lang. So, we're going to look for the degree of freedom 15. And ang kanyang alpha ay 0.05. O yung tinatawag nating 95% confidence. Kaya ang value doon, o yung tinatawag nating coefficient ay plus or minus 2.131. Okay, makikita nyo ito sa table. T distribution table with the degree of freedom 15 and alpha 0.05. So the critical values are positive or negative 2.131. Then establish the critical regions. So check natin sa normal distribution. So ito yung kanyang sketch. So kinuha natin ang kanyang critical values. Isang negative 2.131 na nasa negative part at yung sa positive part ay positive 2.131. Then yung rejection region below sa negative 2.131 ay rejection region at more than positive 2.131 yun naman ang nasa rejection region. Okay? Then select the appropriate test statistic. Ang pwede natin gamitin ay ang test statistic T. So we are going to use the formula. Ang formula natin is T is equals to the quantity of X bar minus mu sub 0 times square root of n all over S. Based na sa ating given, ang ating given mean ay 7.6 at ang ating target mean mu ay 8.0. So we have 7.6 minus 8.0. Then square root of sample size 16 at yung standard deviation natin ay 0.4. Okay, so unahin muna natin itong numerator, 7.6 minus 8.0, and that is 0.4. Square root ng 60 naman ay positive 4. Negative to mas malaki kasi yung negative 8. So kaya negative 0.4 times 4 all over 0.4. Then, cancel out na yung 0.4. Ang matitira lang ay ang negative 4 over 1. So ang answer natin ay negative 4. So pagtingin natin sa ating critical region, ang negative 0.4 ay nasa below negative 2.131. So nandito ang banda yung ating value. So that yung ating value found in the rejection region. State the decision rule based dun sa ating graph, ang ating T statistic value or yung ating computed value is found on the negative part and it is below negative 2.131, which is the critical values. Therefore, reject the null hypothesis H sub 0. Compare the test statistics and the critical value. The T computed is negative 4, which is less than dun sa T critical value, and that is negative 2.131. Based on the decision rule, decide whether to reject the null hypothesis or to fail to reject the null hypothesis. The null hypothesis is rejected. Then the last interpretation, the sample evidence warrants the rejection of the null hypothesis. The sample does not belong to the population whose mean mu is 8.0. Indeed, there is a significant difference between the means. And that's all.
Okay, so for example 2, the t-test using one sample mean. The Human Resources Department of a company developed a skilled competency test for a certain group of skilled workers. The HRD asserted a tentative hypothesis that the arithmetic mean grade obtained by this group of skilled workers is 100. The test was given to a random sample of 16 skilled workers and the results are, ang nakuhang result, yung ating sample mean is 95 and the standard deviation is 5. Is HRD's tentative hypothesis correct at the given alpha of 1%? Ayan. So ito ay Human Resources Department. So tingnan natin kung ano ang magiging null hypothesis at alternative kasi dito sa ating situational problem. So ang hypothesis natin, the arithmetic mean grade obtained by skilled workers is 100. Yun yung ating null hypothesis. So kaya ang magiging kanyang symbol, so kung siya ay 100, so is equal to 100. Then ang magiging alternative naman ito, the mean grade obtained by skilled workers is not equal to 100. Not equal naman. Okay ba sila, diba? Ibig sabihin, dun sa ating null hypothesis, pwede natin ilagay ng ating population mean, mu, is equal to 100, diba? Yan. Tapos yung ating alternative naman, ang mu natin, kaya symbol is not equal to 100. Okay. Next, sabihin natin yung ating alpha. So, ang alpha natin ay 1% or 0.01. Then, ang ating test method, syempre ito ay t-test. Kasi 16 lang yung sample size 16, so less than 30. Kailangan natin makuha yung degree of freedom. Okay, so ang degree of freedom natin ay, dahil ito ay one sample, kailangan gamitin ay df equals n minus 1. So, we have 16 minus 1 is equal to 15. And so, kapag tingnan natin ang critical value, no, makikita ito sa ating table. So, kung bakit ang ginamit natin ay plus minus, kasi nga, pasok siya sa tinatawag natin na two-tailed test. Kung bakit siya ay two-tailed, pag tingnan natin yung ating alternative, not equal, so non-directional. Ito yung symbol natin, not equal. So, it is non-directional. Kaya, titingnan natin sa two-tailed ng table. Sa ating t-table, makapansin nyo, tingnan mo ang df or degree of freedom na 15. Okay, kung meron kayong table, pwede nyo rin tingnan. So, 15 degree of freedom, then punta mo ang 0.01. Makikita natin doon ang 2.947. Okay? 2.947. So, meron tayo ngayong critical value. Okay. Then, next, kuhanin naman natin ang computed value. Yung computed value na. So, ang gagamitin natin formula, And then ang T computed value ay yung sample mean minus population mean, and that is 95 minus 100 times the square root of sample size 16 over standard deviation 5. So by computation, 95 minus 100, that is 5. Divided by 5, 1. Then square root of 16 is 4. Diba? Pwedeng positive 4 or negative 4. Walang problema kasi naka-two-tailed naman tayo, no? So naka-two-tailed. So again, compare natin dun sa ating critical value. Pag check natin, ang ating computed value ay 4. So i-analyze natin gamit ang ating normal distribution. Okay, so ang ating critical value ay nasa 2.947. So malapit na siya sa 3. Lagyan natin dito ang 1, 2, 3. So nandito ang ating 3, nandito ang ating critical. At sa kabila din, negative 1, negative 2, negative 3. So malapit sa 3, nandito ang ating critical. Okay, so ang ating computed ay 4 or negative 4. So pwedeng higher sa right side, nandito yung portion higher. At lower naman pag sa left side. Okay, nandito naman siya, lower, diba? Okay, so ibig sabihin, yung ating computed value ay nasa critical region. Ayun tinatawag natin na rejection region. Nasa rejection region. Nandito yung ating 4 at yung negative 4. So meron tayo ngayong decision. Diba? Ang magiging decision natin, since ang computed value of 4 is higher than the critical value of 2.947, therefore, the null hypothesis is reject. The null hypothesis is reject. Okay? So kung ma-reject ang null hypothesis, ang magiging part na ngayong conclusion ay ang alternative hypothesis. Okay, reject ang ating null hypothesis. So conclusion natin, at 1% level of significance with degree of freedom 15, the arithmetic mean of 100 obtained by the skilled worker is not true. Okay, so ang next sample natin ay the t-test using two sample means. A taxi company wishes to find out whether the use of the radial tires and belted tires provide the same fuel consumption. 12 cars were driven twice over a prescribed test course, and for each test a car used a different type of tire, radial or belted, in random order. So the data obtained were recorded as follows. Type of tires, yung radial and belted. Ang sample mean ng radial ay 5.75, doon naman sa belted ay 5.61. Standard deviation of 1.10 sa radial and 1.30 sa belted naman. At 0.01 level of significance, we can conclude that the cars equipped with radial tires and belted tires provide the same fuel consumption. Assume that the data are normally distributed. Okay, so ito yung ating situational problem. So, again, ang ating first move ay kuhanin natin yung null and alternative hypothesis. Okay, para sa ating null hypothesis, there is no significant difference on the fuel consumption of cars using radial and belted tires. Okay, kaya ngayon ang magiging reported mean natin ay sa group 1 doon sa radial at doon sa radial or sa belted ay equal lang. Equal, kasi sabi doon ay there is no significant difference. So, equal. Yun yung ating null hypothesis. Ngayon, pagdating naman sa alternative natin, there is a significant difference on the fuel consumption of cars using radial and belted tires. So may pagkakaiba para sa ating alternative. Ang mangyari ngayon sa ating notation, so yung mu1 natin and mu2 are not equal. Kasi meron tayong, sabi ng alternative, there is significant difference. Okay, so dito magbabase yung ating magiging conclusion, decision and conclusion. Okay, check natin ang level of significance. Ang nakalagay sa ating information ay 0.01 or 1%. Then again, ang ating test of statistic ay t-test ang gagamitin natin. Dahil nag-base tayo dun sa sample size, ang nakalagay sa sample size natin ay 12 cars. So below 30. Then ang alpha natin ay 0.01. Yung degree of freedom natin, 12 for the radial tire and another 12 doon naman sa belted. So 12 plus 12 minus 2 kasi ito ay 2 groups or 2 sample mean kaya minus 2. Then we have 22 for the degree of freedom. Kailangan natin ng degree of freedom at ang alpha para makuha natin ang tinatawag natin na T critical value. Then bakit naging two-tailed? Base dito sa ating test statistic. Sapagkat pag tingnan natin ang kanyang alternative, yes, ang ginamit nating symbol ay non-directional. Kasi sabi doon ay there is significant difference. So non-directional, pwedeng right and pwedeng left. Okay, kaya two-tailed. Again, pag tingnan natin ang kanyang magiging T critical value, base doon sa ating table. So tingnan nyo na lang sa inyong T table, makikita ang tingnan nyo ang degree of freedom na 22 at yung alpha niya 0.01. So magkocross yung dalawang yan sa point na plus or minus 2.819. Okay? Pwede nyo siya verify using your T table. Okay? So, meron na tayong T critical. So, susunod natin ay yung computed value using T test. Ngayon, sa part na to, dalawa ang gagamitin natin formula ay yung para sa 2 sample mean. Okay, so yan ang ating gagamitin na formula. Kasi, nakabase tayo sa 2 sample mean. Yan, so ito yung ating formula. Then, yung para sa radial tire, ang sample mean ay 5.75 minus. Doon naman sa velted tires ay 5.61 ang kanyang sample mean. So, kuhain lang natin yung difference nun, absolute value. Then, divide natin sa square root ng variance ng sa radial at yung variance naman sa velted. Then, divide natin sa kanilang tinatawag na sample size. So, using the formula, kakaroon tayo ng result. Pwede nyo siyang i-direct solve. So, ang magiging T, computed value natin is okay, yes. Ayan, okay, yes. Ayan natin, ang sagot. Yan. So, ang magiging sagot natin ay 0.2848. So, pwede nyo rin siya i-verify kung tama yung sagot natin. Gamitin nyo lang itong ating computation. So, 0.2848. Then, compare na natin ang yung T critical value at itong T computed value. Okay, para sa decision, since the T computed of 0.28, rounding off na tayo, is less than the T critical value of 2.82. Obviously, diba mas mababa yung T computed. Then, the decision is fail to reject the null hypothesis. Fail to reject the null hypothesis. Kasi pag tingnan natin sa interpretation gamit ang ating normal distribution, gawa tayo ng normal distribution. So, yung ating critical value ay 2.82. So, malapit na siya sa 3. Okay, bilang na tayo 1, 2, 3 positive. So, nandito ang part ng 2.82. Ganun din sa left, negative 1, negative 2, negative 3. Kasi ano naman yan, two-tail. So, nandito ang ating critical. Okay. Then, ang mangyayari dahil ang ating computed ay mas mababa, so nandito sa loob. Wala pa siyang 1. Wala pa nga 0.5 eh, nandito siya sa loob. Dito yung ating 2.28. Okay. Or 0.28. Ayan, 0.28. So, pasok siya sa tinatawag natin na non-rejection. Or yung acceptance region. Non-rejection to, di ba? Itong part na to. Non-rejection. Okay? So, therefore, fail to reject null hypothesis. So, pwede na tayo agad makakuha ng ating conclusion. So, ang conclusion natin ay yung mismong null hypothesis. There is sufficient sample evidence to show that there is no significant difference on the fuel consumption of cars using the radial test and using the radial tires ito and velted tires at alpha of 0.01. Okay, so kung ano man gamitin na gulong, radial man or velted, ay walang pagkakaiba para sa fuel consumption.